Alright, so let's take a look at the notes for section 8.7. We're looking at powers and roots of negative numbers. Up till now, what we've really tried to do is we've limited the values that we've been working with when we worked in chapter 7 and in chapter 8 for powers and roots. We really were limiting things to positive values. And the reason for that is really kind of the big idea for this section, and that is that when we're dealing with negative numbers, we need to be very careful how we're doing that. So great care must be taken when dealing with nth roots of negative numbers. Okay? When the nth roots are not real, then the root of the product there may not be true. So that's kind of what we want to think about as we're going through stuff for 8.7. So today, as I'm going through the notes for 8.7, we want to really think about what's defined and what's not defined and how we apply those rules. Alright, so if we go back to chapter 7 and all of the different properties of integer powers that we studied, when I looked at them, we were always looking at it in terms of a positive base. Well, what we're saying here is the following. All the properties of integer powers of positive bases that we studied in chapter 7, they're also going to apply to integer powers of negative bases. Now, it's important that we understand that that's with integer powers. Okay, so all those rules will apply. So if I look at an example like this one, -5 to the -4th and -5 to the 7th, and I want to write that without exponents, what we can do is we can apply that rule where I can say the product of powers rule, which just says, hey, -4 plus 7, which is equal to -5 to the 3rd power. And then I can go -5 to the 3rd power. Well, that's just -5 times -5 times -5, which would be -125. So all of those type of properties all apply with negative numbers. Alright, so that brings up the next question, which is, are there non-integer powers of negative numbers? So if it's not an integer, what if it's a fraction? How do we deal with that? Well, non-integer powers of negative numbers are not defined in this book. So when we're thinking about non-integer powers, something like -9 to the 1/2, now all of a sudden we're starting to say, hey, there's some differences between writing something in a radical form and writing something in a fractional form, because -9 to the 1/2 we're going to say is undefined for this course. Now, we're going to find later on that there are some things that we can define with rational exponents like that when I have a negative number, but for purposes of this course, they're going to be undefined. Okay. However, if I think about this in radical form, -9, and if I take the square root of -9, we already know that's equal to 3i. So this is where we're starting to see some differences between writing something in a fractional form and radical. Alright, now what I'd like to do is I'd like to look at the expression the nth root of x. And when we look at the nth root of x, we're going to look at it in a few different ways. To begin with, we want to think about when x is negative. Okay, so the x value is negative, and n is an odd value. Alright, well, the definition for that is the following. When the nth root of x, when x is less than 0, we're going to say when x is negative and n is an odd integer greater than 2, the nth root of x stands for the only real nth root of x. So there is only one real nth root of x, and this is going to stand for it. So if I think about the 3rd root of -8, there's only one real one, and that's -2. So we're going to say the 3rd root of -8 stands for that one real nth root of x. So let's take a look at this example then. So if I say evaluate the 5th root of -32, well, there's only one number that I can multiply together that's real, and I can multiply it together 5 times and get -32, and that number would be -2. So we would say that the 5th root of -32 stands for -2. Alright, now we want to look at the exact same thing, the nth root of x, when x is negative, but this time we're going to say, well, what if n is even? How does that work? Well, if I think about the nth root of x, it's not defined when when n is even and x is negative. Think about the graph of a power function that's even. Remember, it goes something like this. And if we have a negative number, it's going to be down here, and they're not going to intersect at all. Therefore, if I think about an even value of a negative, or excuse me, an even root of a negative number, it's always going to be an undefined value. There are no real fourth roots of negative 16. There's other fourth roots of negative 16, but none of them are real. Therefore, we're going to say the fourth root of negative 16 is undefined. All right, this leads to the last concept for today, and that's the idea of the nth root of a product theorem. So we're going to look at this concept right here. Well, what we're saying is if I take the nth root of x and the nth root of y, if they're both defined, and this is the key thing, I'm going to highlight that, they have to both be defined and are real numbers. So if they're defined real numbers, then we can say the nth root of xy is equal to the nth root of x times the nth root of y. But there's a couple key things here. Number one, each one of them has to be defined. And number two, they have to be defined as real numbers. In that case, then we can say the nth root of xy is equal to the nth root of x times the nth root of y. So if I'm saying the fourth root of negative 16, let's try that again. The fourth root of negative 16 here, make this a negative, times the fourth root of, say, 8, I can't multiply those together because the fourth root of negative 16 is not defined. However, if I look at this example down here, it says simplify the third root of negative 1250 and write your answer as in radical form. Well, now I have the third root of a negative number. Since that's defined, I can go ahead and break that up into different parts. For instance, I can rewrite this as the third root of negative 125 times 10. The reason why I picked negative 125 is because that's a perfect third root number. So then I can break that up and say, well, that's the same as the third root of negative 125 times the third root of 10. So I'm applying this nth root of a product theorem. Okay? So I'm going from this to this. Now, the third root of negative 125 we know is 5, therefore I can write this, negative 5, therefore I can write this as negative 5 times the third root of 10, and I've simplified this expression right here by using that nth root of a product theorem.